Well, welcome everyone to Landfill Waste Becomes Building Insulation. This course is approved for 1 hour in continuing education units. Among them are AIA Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. This session is brought to you by the nonprofit, the GreenHome Institute. My name is Brett Little. I'm the program manager here, and I'm going to help moderate this session. Before we get started, I want to say a huge thanks to one of our top tier sponsors, Rheem. Check out the new Rheem ProTerra, an energy efficient, quiet, and all electric hybrid heat pump water heater. The future of water heating is finally here. 40, 50, 65, 80 gallons is all available. One thing that's really exciting is they just took home the gold award from the 2021 Edison Awards. So you can check that out on their website, real exciting. You can see how they stack up and compare to both traditional gas and electric water heaters. Much more energy efficient, quieter, better warranties, leak detection, and working with automated home systems. So how these systems work, you can see at the top, they pull in air out of, pull it in out of the air, the heat out of the air, and they use refrigerant cycle to pump that heat and use it to heat the water up to nearly 400% efficiency. There's lots of different ways you can install these systems, and if you're using a multi-family project, you can chain them together to get as much water as that you might need. As I'd mentioned, you can use their application for Wi-Fi built-in technology to connect to it, track your energy use to see how it's working, leak sensor detection, and operation modes. And basically how that works is when you're trying to do peak load shaving and make sure your water heater isn't working from whatever your peak time is, wasting energy and costing you money. So you can have it pump water and heat the water before that peak time hits, and then have it shut off and then turn back on afterwards. That's how I use it. I have one too, and it's been working just great. So you can check them out over at reamproterra.com. And thanks to our second tier sponsor, T-Stud, they make structurally insulated framing systems, so insulated studs for behind the walls so you can avoid the hassle of exterior insulation. They come pre-insulated or bare naked, which you can use any insulation you like. Check them out over at tstud.com. So we're going to be talking a little bit about insulation and sourcing it from a more sustainable material selection as far as landfill waste goes, and that really plays well into the LEED certification process or any of the green building processes. There's different ways you can pick up points there, and that's going to be some of the lessons learned we'll discuss after that. So we're talking about environmentally friendly preferred products. There's some credits there. EQ Low Emitting Materials, so healthier materials. And then, of course, taking our existing housing stock and making them more energy efficient always helps with LEED as well. And so after the discussion, we're going to talk a little bit more to the connection to the green building points, but those are some of the takeaways we hope that you'll have from this session. So with that, I'm super excited to introduce you to our speaker, Madeline Walker-Miller. Madeline is the founder and CEO of Nextiles, a Detroit-based textile recycling company that converts textile waste into building insulation. Her professional background focuses on reducing textile waste and its harmful impacts to our natural environment. Her company specializes in creating secondary uses for textiles and engaging more Detroiters in creating a circular economy solutions. She is an alum at Spelman College and earned her master's degree at the Coastal Zone Management from the University of Miami's Rosenstiel School of Marine and Atmospheric Science. Madeline's passion lies in empowering young Black people and people of color to embrace environmental, sustainable behaviors. And I also appreciate that she, as of 2021, is a board member at GreenHome Institute and chairing our marketing committee. In her spare time, she enjoys family outings and playing with her boxer, Maximus. So with that, Madeline, I will turn it over to you. Thank you for joining us, and please do take it away.
Thank you, Brett. Let me confirm that you all are able to see my screen. Good?
Looks good.
Okay. So hi, everybody. As Brett mentioned, I'm Madeline Miller, the founder and CEO of Nextiles, and we are a Detroit-based textile recycling company working to help businesses manage their fabric waste and to recycle some of that pre-consumer fabric waste into eco-friendly building insulation. So just to give a bit of background before we jump in, I am a native of Detroit and an environmental scientist. And I created this business because while most people understand the negative impacts that plastic have on our environment, a lot of people don't realize what fabric is doing to our resources and how rapidly fabric waste is growing. And the fact that 85% of it is landfilled or incinerated poses, a major threat to our spaces. And so in 2018, I started a master's program, as Brett mentioned, at the University of Miami. And it focused on marine and atmospheric science, but I actually had no background in that space. And so I started to work just to get a really basic understanding of ocean plastics and some of the other materials that I commonly heard of in terms of what would be in our water bodies. And while conducting this research, I was really shocked to discover that all of the plastic in the ocean is not from bottles and containers, which is a lot of the knowledge that's out there. And so I learned that such a large percentage of it is actually from clothing and textiles. And during this process, I became really familiar with the fashion designers and car companies that send tons of scrap fabric to landfills. And an interesting thing that I learned is that most of these companies could not use any recycling options if they wanted to because they just didn't exist. And so this is how my business was born. And with the company that I've created, our goal is to essentially prevent fabric waste from ever entering landfill so that it doesn't end up in our oceans and food systems. To give a bit more context, globally, 80% of textiles are landfilled or incinerated at the end of life. And once landfilled, natural textiles can take several years to decompose, while synthetic fibers, on the other hand, can take up to 200 years to decompose. And during this process, they're shedding plastic fibers and leaking chemicals and dyes into our soil and water. And so it's really important that we become familiar with and begin to circulate these facts because one, the growth of textile waste is right now outpacing every other major category of waste. And two, global textile waste consumption is expected to increase by 63% before 2030. And so our solution, in short, for this type of waste is to pick it up from manufacturers that are local to Detroit and convert it to low dust, eco-friendly building insulation. And so we know that building insulation is the most cost-effective recommendation to help reduce heating and cooling bills. And in our case, we're creating a blown-in that'll be used in wall cavities, attic floors, and ceilings. And on this side, you'll see the type of industrial shredder that we use to convert our collected materials to that loose fill insulation. In our case, the mostly denim feedstock that we're currently using, it goes through this process. The hardware is removed from the denim, and it is converted to a material that is the consistency of the last photo that you see at the bottom. And so this sort of machine can easily process denim and other similar cotton materials, but it does not typically work well with spandex and some of the stretcher materials. And so where we're collecting those, we typically try to distribute those spandex materials to other local designers. This is an image of our minimum viable insulation product. And so it is a shredded cotton and synthetic fabric blend. And it's a bit thicker than the majority of the traditional blown-in insulation on the market. And so we've learned that we have to use a vacuum mechanism during the install process. And it contains about 85% recycled cotton and 15% synthetic fiber. And so in this video on the left, and hopefully it's playing properly, you can see it being blown into a wall cavity during a test for blowability. And so this is where we discovered that it doesn't work very well in a traditional insulation blower. And so as we move into standards testing for the product, you can see on this slide, these are some of the early tests that that are going to be required. ASTM C739 is looking at composition and physical properties of a loose fill. E970 is a flame test, and C518 is testing for thermal transmission with a heat flow meter. And of course, in the process of us having this testing done, we're going to grow to understand this product's R value and anything that we can use or do to enhance that. These are some of the figures around market size, and in the US, the demand for residential building insulation is growing. Building codes that require more insulation per home and the home retrofit market and how that space is being used to combat climate change are two of the main growth drivers. President Biden's clean energy plan specifically includes retrofitting 4 million commercial buildings and weatherizing 2 million homes over 4 years, which is going to create at least 1 million good paying green jobs. And so we're moving in a direction that eventually the reuse of textiles and similar materials will become our norm. And so our goal is to capture just a really small percentage of the US green insulation market as we move out of the product development space and release that. The fact that the Midwest has a much older housing stock than much of the country, and the trend of increased home improvement spending makes the Great Lakes region an ideal area to market blown-in insulation to. And for example, in Detroit, where we're based, 60% of the city's housing stock was built before 1970, making it, of course, more than 50 years old, and that presents a really great opportunity for insulation upgrades in the residential retrofit space. And in terms of our revenue model, just to give some information on that, depending on what a company is currently paying to dispose of its waste, we charge up to $2 per pound to pick up from manufacturing centers. We tend to be a bit flexible when it comes to nonprofits and groups that have recycling and using more sustainable methods at the center of their mission. And this strategy fits really nicely with a lot of companies' corporate social responsibility models. And then for the sale of our insulation, we are targeting a price point of $1.40 per square foot, which of course, as we complete product development and better understand the market, could change. Here are some of our milestones and some of the things that we've done since the launch of this business in 2020. Of course, we've completed our website and a lot of startup accelerators and things of that nature. And so this year we hope to complete the product testing, that ASTM testing that I mentioned in the previous slides, purchase a small industrial shredder because we do not have an in-house shredder, and that's something that's going to be really important as Michigan and our region move into the textile recycling space, and to conduct a pilot manufacturing program. And so for that pilot, we're looking to install our insulation into the walls of 10 homes, gather some case study research, and if all of that goes well, we're going to make adjustments and launch full manufacturing at the beginning of 2022. And so I know that was a really, really quick presentation, which leaves us quite a bit of space for questions and things of that nature. And I know Brett has some lead information, but I'm incredibly excited about Nextiles and launching our product. And I've provided some contact information on this slide for any questions that you all are unable to ask during this session.
Awesome. Thank you, Mal. Can you hear me all right?
Yep, I can hear you okay.
All right, great. I'm attempting to jump into a couple things, but yeah, we do have a couple questions here, and I want to get to those. But before I get to those questions, let me just, where are we at here? All right. Can you see my screen all right?
Yes, I see it now.
So just real quick from the LEED standpoint, you know, where some of these opportunities fit in. The very first one, of course, is the environmentally preferable products. And so that's a materials and resource section. And there's two options here. Actually, the first option within this one is locally sourcing, but they've moved that to just particular types of materials. So, for example, aggregate and framing. So, absolutely, if the materials came from the local community and went back into insulation, that's great. Unfortunately, there's no known credits for that because they've just moved the local production to specific things. But anyway, the one you'd want to focus on is option 2, environmentally preferable products. And down there at the bottom, you can see there's 2 different ones that kind of seem like they might be the same. Reclaimed materials, salvaged, that wouldn't be the correct one. So in this one would be talking about 25% post-consumer content. So that was, content that was made and used by a consumer, obviously way beyond 25% here. So maybe some additional innovation points if you ask. We'd have to look into that. So that's kind of where that would fit into LEED from that perspective. And then from an air quality perspective, in the environmental quality, indoor environmental quality section, the very last credit, low emitting products, there is if insulation can meet the California section 01350 or otherwise known as CARB 2. If it actually can be proven to meet that and verified, there's a half credit there. And again, in the old days, we used to just be able to accept a manufacturer's report. Under the new version of LEED V4 and V4.1, it actually has to be certified to meet that CARB 2 standard. So that's important to know to ensure less off-gassing and better air quality for the occupants. And if not already obvious, the whole reason we use insulation is to keep energy in, to keep heat in during the winter, to keep it out during the summer. So when you're doing LEED, you'll use the HERS index rating. And with the HERS index rating, you'll get a better performing score based on more insulation that you have. In many cases, this type of blown-in will perform better and install better than batt insulation. So you're going to get, ideally, a better score, a better energy score, which is going to translate within the LEED energy and atmosphere section to a better score for your energy use. And so those are some of the connections there with LEED. And so, yeah, just real quick for those of you looking to get your continuing education certificate, check your spam after this session ends from customer care at gotowebinar.com, and you can pick that up, take that quiz. For those of you watching this in the future, not right now, on demand, take that quiz with an 80% passing rate. You can check it out on our Thinkific channel or USGBC's channel. Get that and you can pick up your Con Ed. And again, a huge thanks to our top tier sponsors and our volunteers and our board members, including Madeline here, who allow us to do what we do. So one of the specific questions that came in here, Madeline, was a lot of questions about cost, and a lot of questions about that $1.40 per square foot and how that fits into thickness or volume pricing.
Can you hear me okay?
Yeah, now I can.
So one of the things, and I apologize for the ringing if you hear that in the background, but one of the things that has posed a major challenge for us during the pandemic is sourcing that feedstock. And so I think that is going to play a major role in the price of the product, but the $1.40 is something that we're very much exploring. Again, we haven't even completed that product development or testing phase, and so that's not certainly not a hard number.
Got it. Thank you. So and then the next set of 6 different people asking on the R value side. I know you're still in your testing phase. I mean, do you have an anticipated R value that you're looking at or hoping to achieve?
Yeah, we have had a lot of time spent with students through a university partnership, and one of the tests that they sort of conducted with a mechanism that they created, so it's not an official test, produced an R value of 3.1. And so we are going to, of course, continue exploring that and have some official testing done to confirm that.
Mm-hmm. And here's another great question on the follow-up to R value is moisture. And, are there any risks with humidity and moisture, or are there less risks with a material like this? I think, especially in existing homes where you're blowing in insulation, especially into walls, in the past, there was this huge movement to fill every single wall with cellulose. And then it was like, wait a minute, if we don't fix, especially if we don't fix the structure itself and water gets in, it's going to cause a huge problem. But even outside of that, just thinking about, moisture and how it holds moisture, I mean, what are your thoughts there? Or what are you seeing in your testing?
Mm-hmm. So one of the things that we're exploring, we knew from our early research that a lot of the loose fill insulation on the market is treated with different boric acid compounds and different borates to address that moisture, as well as create insect repelling properties and even to enhance R value in some cases. And so, with us using recycled content and marketing an eco-friendly product, we really want to use a treatment with the smallest boric acid concentration possible. And so that's another thing that we're exploring with students. And we're not wanting to use the most commonly used compound, but it is anticipated that will help us to address moisture.
As far as installation goes, you said you were going to be using a different type of blow-in mechanism. Will that require more hands-on training, or will it, to some degree, just install the same? It's just a different type of blowing system.
Yeah. So through our our really robust customer discovery with insulation contractors in Michigan, we've learned that while, of course, the blower that we used is new to the market and quite honestly pretty expensive, but we did learn that most insulation contractors do have that vacuum mechanism to pick it up. And so we don't anticipate any sort of additional cost. And it does work in a traditional insulation blower, but there is a bit of clogging.
Got it. Was there any consideration to make this a rigid or a bat instead of a blown-in, or both maybe?
Yeah, one of the other things that we're doing is exploring using, we have two things going at one time, but we're exploring using, creating a material not with denim feedstock, but with PET fleece that is a result of the automotive manufacturing space. So it's coming off the line and it's actually cut in these really interesting shapes to be used as engine insulation, but that is the material that we're exploring for bat. And so obviously with us being Detroit based and having those automotive ties, that piece is really exciting. And then that material is already flame treated because it's prepared to be installed in vehicles. But we have not yet explored a denim bat insulation product.
Right. So beyond the ASTM standard, as far as the CARB air quality testing, the other question is, are you planning on looking at your product getting tested for other harmful chemicals that might be present in denim or fabric? So for example, they're asking about the HDP process or the disclosure statements, talking about some of those transparency. I could even think of the Living Building Challenges Red List program. So have you looked into any of those?
We have not yet looked into any of those. I think that'll be kind of the latest phase of our testing process, but we haven't looked into exploring the contents of that denim. But we have really strong relationships with some of the denim shoddy suppliers, some of the companies that conduct our shredding. And there's typically, with any of the materials that they recycle for us, three sort of main chemicals that they're testing for, which I can't think of offhand, but in the interest of the employees working in the space and whatever the secondary use might be, we do know that it can't contain those three harsh chemicals.
Sure. You had mentioned at the beginning something about like spandex and a few other things you couldn't accept, and that you give them, you're trying to work to give those to somebody else. But does your system have the ability to easily sort those out, or does that take quite a bit of effort before it goes into the shredder?
It takes quite a bit of effort, and we typically, if we accept spandex, it's typically on a roll so that we don't have to sort it out of other large shipments. And so that makes it really easy to kind of put back into Detroit's designer or fashion design ecosystem. But in terms of processing it through a shredder, some companies do it, but it's almost impossible because it melts on the face of the shredder, and then it'll interrupt future shredding, essentially.
Sure, sure. I was thinking back to a time when I met with the sustainability director of the West Michigan Goodwill out here, and I remember sitting in their office, and we're just talking about sort of this dream that they had where, any single material that, right, because so many things get dumped into Goodwill, right? And just recently about some of these news, there's been a lot of problems with that, but there was this dream that there would be a place for that all to go in some market somewhere in the world to be recycled. And I don't think it ever, unfortunately, I think it was a great goal, but I don't think it ever worked out so well, which is probably why we hear these warnings like, don't drop your junk off at Goodwill. So I guess I'm just thinking like, I've got these old shirts sitting on their cotton, right? What do I do with these things? Is that like where that, that's where something like this could go and turn into insulation, or you tell me.
Yeah, so one of the things that we're really excited to do once we've kind of completed, we're still in startup mode, but once we've gotten a bit more time under our belt, we're excited to explore using post-consumer waste, because right now everything is pre-consumer manufacturing waste because we don't have the resources to address that sanitation piece. And so, if we're collecting pre-consumer waste from all over, even just Michigan, one, it poses an issue with consistency if we're looking to use it for our feedstock. And then two, yeah, we just don't have the means to process that right now. But we hope that will be a solution. We get so much outreach with people, that want to give us their old clothing. They've become familiar with the fact that with so many of the collection centers and things like that, that material is eventually landfilled. And so, yeah, we hope to be able to accommodate that once we've put some more time in the pre-consumer space.
Yeah, thanks for correcting me on that. I think I had those swapped earlier, where I mixed up pre-consumer and post. So I had said this was under the pre-consumer or post-consumer one, but I was wrong. It's pre-consumer, but for LEED. So I want to make sure I make that correction. And no, it's just 50% you have to be there. So you're still good because you said 85% cotton recycled anyway. So that's good to know. You had mentioned on that note the sanitization. So it's almost like you're saying if people were to give these things up, they'd have to be washed or cleaned in some way as part of the process first.
Yeah, and one of the things that which it kind of, if we're working to minimize the amount of resources that we're using, it kind of works backwards. But one of the things that'll be important if we ever want to explore that space is having an industrial washing mechanism to process it before we start to find secondary uses for it.
Right. What is the typical, I don't even know how to ask this question. Maybe you can help me ask it better, but like what is the typical waste that's generated by, pre-consumer waste that's generated by these industries?
Mm-hmm. So it really depends. We have clients from smaller manufacturing centers that specialize in maybe just coats or pants and things of that nature. And then on the other hand, we have people from people who are generating a 40 cubic meter container of waste each month. And so it really just depends on the client. Some of the clients are able to recycle all of their waste, and some of them are giving us just a small fraction of what they generate because maybe they're using a lot of spandex and things of that nature. And so the range of what we're collecting is pretty wide.
Sure. Yeah. Awesome. Well, I don't see any other questions here, Malin, but I really appreciate you joining us, and it's good to see you out there virtually. So I guess where can people go to learn more information or contact you if they have any more questions?
Mhm. There is a bit of contact information. I think you're screen sharing, but our website is nextiles.org. Our Instagram is at nextilesdetroit. My email is madeline@nextiles.org, and we do have a business number, but I provided my cell on this slide in case anybody wants to contact me directly.
Great, Madeline. Well, it's good to see you. I appreciate your time. I know we'll be in touch soon, so thank you so much.
Thanks, Brett. Take care.
Yep, you too.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.